Determine all solutions for the following equation over the specified domain. So the equation is 2 sine x minus the square root of 3 equals 0 for x is an element of 0 to 4 pi. So when we consider this domain, 0 to 4 pi is in fact 2 periods of the sine graph. Because sine of x has a period of 2 pi, so 0 to 4 pi contains 2 periods, which is the same as going around the unit circle twice when we're looking for our solutions. So 2 sine x minus root 3 equals 0. That's the equation we're trying to solve, but to do this we want to get sine x by itself. So we're going to start by adding root 3 and dividing by 2. So this will give us the equation sine of x is equal to positive root 3 over 2. And now root 3 over 2 is an exact value for sine that we know, and the reference angle for that is pi on 3. So over on our unit circle over here, this is the angle of pi on 3, and we read sine off this value, so that value there for y is root 3 over 2. And now the other quadrant where sine is positive is the second quadrant, because y is also positive in that quadrant. So that means we also have this angle here. If this is theta in the first quadrant, then the second quadrant has the symmetry property of pi minus theta. So we can now work out what the second angle is. So we know that x must equal theta and pi minus theta. Therefore, we have x is equal to the reference angle is going to be pi on 3. And then we've also got pi minus pi on 3. So two of our solutions are pi on 3 and 2 pi on 3. At the moment, we've only got the first two solutions, so the two solutions that exist in one revolution of the unit circle. And now what we're going to do is we're going to go around a second time. So we're going to have 2 pi plus pi on 3 and 3 pi minus pi on 3 as the next two solutions that we get. So those solutions are going to be 2 pi plus pi on 3 and 3 pi minus pi on 3. And another way you can think about getting those solutions is to take one of the solutions and add the period on. And we do the same thing here, we add the period. So when we evaluate all of that, we have x is equal to pi on 3, 2 pi on 3, 7 pi on 3, and finally 8 pi on 3. So they are the four x values that are the solutions to the equation 2 sine x minus root 3 equals 0 for x is an element of 0 to 4 pi. We can also explore this as a graphical solution. So in the blue we have y equals sine x is graphed, and in the red we have y equals root 3 on 2. Because we rearranged this equation so that we could solve sine of x is equal to root 3 over 2. So by graphing both sides of that equation and looking for the points of intersection, we see that the intersections occur at pi on 3, 2 pi on 3, 7 pi on 3, and 8 pi on 3, which are the same solutions we found by hand on the previous slide.